Hi everyone, this is Mrs. Anderson talking, and I'm going to be going through and showing you the notes. This is inside your packet. We're looking at Unit 5, Day 5, solving quadratics by factoring. So we're going to be reviewing factoring, and then we're going to be going forth and solving it. This should all be a review, which is why we're doing this today, and we're going to continue to do this tomorrow just as extra review days because of how important this is for this unit. So now I have my equation, which is in standard form, y equals x squared plus 3x minus 10. And just remember, whenever I write down on my paper, you need to write down on your paper because the sub will be checking this along with the classwork for completion today. So in many cases, like I talked about, we can find the solutions or roots to zeros, x-intercepts of a quadratic equation by factoring rather than by graphing. So then following the steps below to find the solutions of the given equations by factoring. And I will tell you, some of these will be on the non-calculator portion of the PARCC exam, which is why it's so important that we know how to do this without our calculator. So in order to solve this, I'm going to go ahead and set my equation equal to 0. So I am replacing my y value with 0. So I have 0 equal to x squared plus 3x minus 10. Next thing I'm going to do is I'm going to factor. So if you have your factoring flowcharts or your factoring reference sheets, I believe Miss Martin posted one on Schoology for those of you that did not have Miss Martin. If you had another teacher, you may have seen the factoring flowchart. That is something that is also helpful for this. So I look and see this is a trinomial. I'm going to look and see if there's a greatest common factor. There is not. So how I factor trinomials, and I'm going to go through and basically show you all the steps. So if you don't remember how to factor, everything is going to be shown here. Basically, whenever I factor trinomials, I am looking for factors of my AC that add to be B. And when I say factors, what multiplies to give us 1 times negative 10. So in this example, I'm looking for what multiplies to give us negative 10 and then adds to give us our B value. So it's A times C. Remember, your A is your number in front of your x squared, your C is your constant. What goes in the bottom is your sum, which is your B value. So now what I'm going to do is I'm going to think about what are the factors of negative 10. Now, some teachers went through and showed you how to find your factors in your calculator. So I'm going to pull up a calculator. Give me 1 second. Okay, so I pulled up my calculator. In order to find what my factors would be a shortcut, now this is if you have a calculator. If you don't have a calculator, you're going through and thinking, okay, what multiplies to give you negative 10? So you would go through and ask yourself, what are the multiples of negative 10? If you do have your calculator, you're going to go to y equals, you're going to type in negative 10 divided by x. So we type in our AC divided by x, and then I'm going to hit second graph, and this is going to bring up a list of all my factors. So I am looking at the whole numbers, and I'm looking for the ones that add to give us a positive 3. So in my head, 1 minus 10 is negative 9. 2 minus 5 is negative 3. Don't care about the decimals, don't care about the decimals. 5 minus 2 is positive 3. So those are my two factors. So my two factors are 5 and negative 2. 5 times negative 2 multiplies to give you negative 10. 5 plus negative 2 adds to give you 3. So factoring this, I'm going to go ahead and break apart my middle term. So I bring down my first term, x squared. I break apart my middle term, which is positive 5x. This is an x term, so I'm going to include x's on my variables. Minus 2x. Those are my two factors, which if I added them, they would give me back to positive 3x. And I'm going to bring down that minus 10. Factoring by grouping, so I'm going to go through and group these. Grouping, 4 terms, group my first 2 terms and my last 2 terms. So then GCF of the first group, they both have an x. I'm going to pull that x out, factor it out. X squared divided by x is x. 5x divided by x would give me 5. Second group starts off with a negative, so I'm going to divide by a negative. Pull out a negative, actually it's a negative 2. GCF of 2x and negative 10 would be negative 2. So negative 2x divided by negative 2 is a positive x. Negative 2 times negative 10 divided by negative 2 is a positive 5. This will give me my two factors. So my two factors, what do they have in common? They both have x plus 5. And what's left over? X minus 2. You may have been taught a shortcut to this, so because this x value has a 1 in the front of it, I could have just found my factors, and then basically the factors are what goes into the factoring of this because your a value is 1. Now, because I'm solving this, I'm going to set each of these equal to 0. If you need extra paper, please grab extra paper out of your binder and write these steps down so that you have them. So my last and final step is, now that I have my factors are set equal to 0. Since this is multiplication of two factors, I'm going to set each of them equal to 0 and solve. So x plus 5 equal to 0, x plus 2 equal to 0. Solving this, getting the x by itself, subtract 5 on both sides. I get x to equal negative 5. Over here, I'm going to add 2, so I get x to equal 2. This one has two solutions, or zeros, or x-intercepts. Bunch of different names, roots. This one has answers of negative 5 and 2. And we can rewrite this, instead of writing two separate ones, I can rewrite this as x is a set, these little squiggly braces mean set, of answers of negative 5 and positive 2. Nothing in between, just those two exact numbers and those two numbers only. If I am moving too fast through these examples, you are more than welcome to pausing it, going back and basically redoing the problem and slowing it down so that you are able to copy everything down. Okay, example number 1. First thing I'm going to do is factor. Factors of a times c that add to be b. So factors of 3 that add to be 4. Okay, you can either go to your calculator, or essentially 3 is a prime number, so it only has two factors, 3 and 1. And if you notice, 3 and 1, everything is positive here. Those are my two factors. Breaking apart my middle term, x squared plus, bring down my first term, break apart my middle, 3x plus 1x plus 3 equal to 0. Factoring by grouping, because I have 4 terms now. I'm going to group my first two terms and my last two terms together. Take out the GCF. GCF of this first group is x. Divide that out to leave me with x plus 3. GCF of the second group, only thing I can take out is a 1, so I'm going to put a plus 1 in the front, leaving me with x plus 3. Therefore, my factors would be x plus 3. That's what they have in common. And then what's left over, which is x plus 1 equal to 0. Next, setting each of these equal to 0 and solving. So x plus 3 equal to 0. I get subtract 3, so I get x to equal negative 3. X plus 1 equal to 0. I'm going to subtract 1 on both sides. I get x to equal negative 1. So this has two solutions of negative 3 and negative 1. And you can check these in your calculator. Check them by checking your graph. You're looking to see where is that crossing our x-axes in our graph. This one should be crossing at negative 3 and negative 1. And it should be crossing twice. Number 3. So once again, I'm going to set up my diamond. Factors of AC that add to be b. So factors of negative 2 that add to be 1. Once again, negative 2 is a prime number, so it only has factors of 2 and 1. Because this is negative, I know that one of these numbers have to be negative. Since it's adding to be a positive 1, I'm going to go ahead and put the negative on the smaller number, which is negative 1. If you are struggling with that, you're going to go to y equals. You're going to type in negative 2 divided by x. Then I'm going to hit second graph, bring up my table, and my table is going to show me all my factors, which you'll notice there's only 2 of them here that are whole numbers. 2 pairs that are whole numbers, so I'm looking for the one that adds to be a positive 1, which is 2 and negative 1. So breaking apart, x squared plus 2x minus x minus 2 equal to 0. I'm going to go ahead and group. GCF of the first group is x. Divide that out. X squared divided by x is x. 2x divided by x is 2. GCF of the second group starts with a negative, so I'm going to divide by a negative 1. So negative x divided by negative 1 would give me a positive x. Negative 2 divided by negative 1 is a positive 2. Remember, these two parentheses should equal in order for this to work. So that I get my factors. What do they have in common? They both have x plus 2. What's in the front? X minus 1. Set then that equal to 0. Since I have my two factors, I'm going to set each of my factors equal to 0 and solve. So I'm going to set x plus 2 equal to 0. Solving this, subtracting 2 on both sides, I would get x to equal negative 2. Over here, x minus 1 equal to 0. I'm going to add 1 on both sides, so I get x to equal positive 1. This one has solutions of negative 2 and positive 1. Remember, this is where this is crossing the x-axis. So this is crossing at 0, negative 2. Oh, sorry. This is crossing at negative 2, 0. X-intercepts, not y's. And positive 1, comma 0. Next one, number 5. So number 5, I'm looking for factors of 21 that add to be negative 10. So I'm looking for, going to go to my calculator, or you can do it in your head. I'm going to go to y equals, I'm going to type in negative 21 divided by x. And I'm going to hit second graph, looking for the order, for the pair that adds to be a negative 10. So 3 minus 7, no, that's negative 4. Let's see. Did I type it in right? Oh, it should be a positive 21, sorry, not a negative 21. Looking for a positive 21 that adds to be negative 10. So going back into my negatives, I see negative 3 and negative 7. So those are my two factors. So that, using my grouping method, x squared minus 3x minus 7x, bring down that 21. First term, last term, break apart my middle term. Those should combine to give you your middle term. Going through and grouping this, GCF of the first group is x. Going to write that out in front, leaving me with x minus 3. GCF of the second group is negative 7, leaving me with, once again, negative 7x divided by negative 7 is positive x. 21 divided by negative 7 would be subtract negative 3. What do they have in common? They both have x minus 3. What's left over? X minus 7 equal to 0. Solving this, so factoring is done. Now I'm going to set each of my factors equal to 0 and solve. X minus 3 equal to 0. Add 3 to both sides, so I get x to equal 3. Over here I'm going to add 7 to both sides. I would get x to equal 7. So number 5 has solutions of 3 and 7. Number 7, factors of 25 that add to be 10. Just doing lots of examples here. Factors would be 5 and 5. So I would get x squared plus 10x. Oh, I'm going to break apart that middle term to be plus 5x plus 25. I'm going to group. GCF of the first group is an x. Pull that out to get x squared divided by x is x. 5x divided by x is 5. GCF of the second group is 5. Put a plus 5 out in front. Leave you with x plus 5. What do they have in common? They both have x plus 5. What's left over? X plus 5. You'll notice that this is the same factor, so I only have to write it once. X plus 5 equal to 0. Solving this, I subtract 5. I would get x to equal negative 5. This is an answer that only has one solution of negative 5. What this would look like on the graph is it essentially only has a horizontal shift, 1, 0. So it does have a y-intercept up at 25, but it only has 1, 0. It basically comes down, touches the x-axis at negative 5, and then bounces back up. Okay, number 9 on the back. So you'll notice that this one only has 2 terms. So whenever we start looking at 2 terms, first thing we're going to always look for is our GCF. It's a different method of factoring compared to the ones on the front, which were the trinomials. So GCF, x squared minus 8x, and I already see it's equal to 0. So GCF of both of these, I can divide out an x. Now remember, anytime I divide that out, I'm going to put it out front. So x squared divided by x, I have 2 x's, I take one of them out, will leave me with an x. Negative 8x divided by x, leave me with a negative 8. Setting each of those equal to 0, I get x to equal 0. That's the first. Anything with the multiplication, I need to set equal to 0. And then I have x minus 8 equal to 0. Solving this one over here, I get x to equal 8. So this one has solutions of 0 and 8. Number 11. Once again, 2 terms, going to check for a GCF. This one has a GCF of 6x. So I'm going to write that 6x out front, divide it out. 6x squared divided by 6x would be an x. Negative 12x divided by 6x is negative 2. setting each of these factors, this is a factor, this is a factor, setting each of my factors equal to 0 and solving. Dividing by 6 over here, 0 divided by 6 is just 0. Here, adding 2 to both sides, I would get x to equal 2. So this one, 11, has solutions of 0 and 2. Number 13, two terms, no GCF. So this is actually going to be a difference of squares. If you do not remember the formula for difference of squares, you could also see this as x squared minus 0x minus 64. I'm missing my middle term here. So if I'm missing my middle term here, I would be looking for factors of negative 64 that add to be 0. So I could go to my calculator, I could go to y equals and type in negative 64 divided by 0. Looking at my values, I'm looking for the ones that are, not divided by 0, divided by x. Looking for the ones that add to be 0, meaning that they are essentially the same number pair and they cancel each other off. And there it is, 8 and negative 8. So you could go about this like how we were doing the ones on the front of the page, where I subtract 8x, and I add 8x, and then I subtract 64, and you could go about the graphing. If you remember the difference of squares formula, where if I had a squared minus b squared, my factors would be a minus b times a plus b. So because I know my factors are negative 8 and positive 8, how do I get x times x? X squared would be x times x. Negative 64 would be positive 8 and negative 8. Because they are the same number, they're going to cancel off your middle term to leave you with that 0x. Sending that each of these equal to 0 and solve. X plus 8 equal to 0. X minus 8 equal to 0. So that's solving this. I'm going to subtract 8 on both sides. I get x to equal negative 8. This one I'm going to add 8 to both sides. I get x to equal positive 8. So this one has solutions of plus or minus 8. Positive or negative 8. Number 15. So GCF is 81 divisible by 4. Answer is no. It gives you a fraction. So there's no GCF. So now I have two terms, and I notice that 4 and 81 are a difference of squares. So I could see this, like I said above, as 4x squared minus 0x minus 81. Okay? If I see it this way, I have to use grouping for this. So I would be looking for factors of 4 times 81, which would be factors of negative 324 that add to be 0. So this one would be a little bit trickier if you did do it using grouping method like what we were doing on the front. If you remember your difference of squares, so because these are both perfect squares, basically taking square root of 4x squared, so what times what are the same numbers that would give us 4x squared? That would be 2x. Square root of 81 is 9, so I would have plus 9 and minus 9. Setting each of these, 2x plus 9 equal to 0, 2x minus 9 equal to 0. I'm going to go through, subtract 9. I get 2x to equal negative 9, divide by 2, so I get x to equal negative 9 halves. I'm going to add 9 over here to both sides, so I get 2x to equal positive 9, divide by 2, I get x to equal positive 9 halves. So this one has solutions of x to equal plus or minus 9 halves. Last ones for the notes are equations that are not in standard form. So in order for it to be in standard form, I need it to be 0 equal to ax squared plus bx plus c. So before I go through and factor this, I always need to get it equal to 0. So in order to get number 17 equal to 0, I have to subtract 21 on both sides. So that I would get x squared plus 4x minus 21 equal to 0. Now I can factor this. Factors of negative 21 that add to be 4. So looking at my calculator or finding it in your head, factors of negative 21 divided by x. Looking for the ones that add to be a positive 4. So not that one. 3 and negative 7 add to be a negative 4. 7 and negative 3 add to be a positive 4. So those are my factors. 7 and negative 3. Because I have an a value here that is 1, I can factor this the easy method. So what times what will give me an x squared? That would be x times x. What times what did we say would multiply to give us negative 21, add to give us 4? That was positive 7 and negative 3. The reason I wanted to go through and show you the grouping method in the long steps is because tomorrow we're going to be looking at whenever a value is not 1. So I wanted to just give you an introduction to how to do that when your a value is not 1. So setting each of these equal to 0 and solve, I'm going to subtract 7. So I get x to equal negative 7. Over here I'm going to add 3. So I get x to equal 3. So number 17 has solutions of negative 7 and positive 3. And by the way, these solutions tell us that if I plug negative 7 into our equation, so negative 7 squared plus 4 times negative 7, I should get it to equal 21. It should make the equation balance. If I plug positive 3 in, so 3 squared plus 4 times 3 equal to 21. 3 squared is 9. 9 plus 12, it does equal 21. I'm looking for what numbers can I plug in here that is going to make this equation balance. Because I have the x squared, it's not just basic solving like it was before. I have to go through and I have to factor first before I solve. Number 19, getting it equal to 0, I'm going to subtract 7x. So I get x squared minus 12x minus 64 equal to 0. Next step I'm going to do is I'm going to factor this. So I'm looking for factors of negative 64 that add to be negative 12. Going to my calculator, I'm going to go to y equals, plug in negative 64 divided by x. Nope, and I can't type. Second graph to bring up my values, and I'm looking for the ones that add to be negative 12. So 164, no. 2 and negative 32, no, that adds to be negative 30. 4 and negative 16, there they are. 4 and negative 16 are my factors. Because this has an a value, which is 1, it's easy factoring, so what times what will give me x squared? X. So x plus 4, x minus 16. Setting each of these equal to 0, x plus 4 to equal 0, I get x to equal negative 4, x minus 16 equal to 0, I get x to equal positive 16. So this one has solutions of negative 4 and positive 16. 21, I'm going to go ahead and get this equal to a 0, so I'm going to subtract the x squared, and I'm going to subtract the 8x. And I always want this to be a positive a value here. I always want this to be a positive a value here, so if you happen, let's just say, if I happen to go through and subtract the 11x squared, I would get 0 to equal negative 10x squared plus 8x. I would want to go through and divide out a negative 1 out of both of these, out of every single item, so that I ended up with a positive 8x. And you'll see what happens here. 11x squared minus x squared would be 10x squared minus 8x. You will see that I'll get the same answer in the end, just two different ways of going about it. This will have an extra step of dividing by a negative 1. Two terms, I'll notice that this has a GCF. They both have a GCF of 2x. So I'm going to divide that GCF. GCF always goes out front. 10x squared divided by 2x would be 5x. Negative 8x divided by 2x would be negative 4. Setting each of these, 2x equal to 0 and 5x minus 4 equal to 0, I'm going to divide by 2. I get x to equal 0. Add 4 to both sides. I get 5x to equal 4. Divide by 5. I get x to equal 4/5. So my solutions for number 21 are 0 and 4/5. Okay, so what you're going to do is for your classwork, you're going to go through and complete all the even problems. Then whenever you get done with all the notes and all the even problems, you're going to get it checked by the sub or whatever adult is in there, because they're going to mark it on the clipboard that you completed the classwork, which is the notes and the evens from this, and they're going to check to make sure your answers are correct as well. Then they're going to then your homework is on the next page of your packet. So it's Unit 5, Day 5. And it is, you're going to do 1 through 20. You need to see all your work, no credit on Thursday whenever we check it. If you happen to get done with your homework, there is an extra maze activity that the sub can give you that will be extra credit. Thank you. Have a good day. Be good for the sub.